Yeah, so thank you very much, Alex, and thanks for the great talk. So let me share my screen with the panelists on the slide. So, so now we will go into the panel session of the workshop. So we will have four panelists, and today's discussion topic will be on performance testing in DevOps. And the first panelist that we have is our keynote speaker, so Patrick Tuma, and he's a professor with the Department of Distributed and Dependable System at Charles University. And we also have Andy, who just gave an awesome talk. So Andy has 20 plus years experience as a software developer, tester, and architect, and is an advanced for high performance cloud scale application. And he's also a regular contributor to the DevOps community, which is a great fit and will be an amazing experience for him to share the experience for the topic on the panel discussion. And we have Alex, which is also one of the co-organizer of the workshop. He's a staff performance engineer at MongoDB, responsible for various performance testing and optimization of the MongoDB server. And he has specialized in performance testing since 1997. And he also has a lot of experience in various industrial roles, such as Oracle, Athena, and Intel. And he's also very engaged in discussion and research on performance-related topics. And finally, we have Wei-Yi Song. And Wei-Yi Song is an associate professor at Concordia University. And he's also a researcher and in ultra large scale systems. His research interest includes big data, software engineering, and software engineering for ultra large scale systems. And he has also won several distinguished paper awards at conferences such as ICSI. And so today for the panel discussion, I think that we can try to keep it more informal, so that the participants can also have a lot of engagement with the panelists, and the panelists can share more of their experience and background. So since performance testing in DevOps is a very broad area, and then today we saw that Patrick talked about his experience on benchmarking in the JVM and how that can be integrated in the DevOps practice. So maybe we can first ask the panelists to share their own experience and their own take on performance testing in DevOps and the challenges that they see and encounter. And we can start with anyone, like any panelist can start.
I'm happy to give it a try to start.
Yeah.
So I think what at least I see, and my performance world and experience is very much focused on application performance. Okay, so if you want to hear something about optimizing, I don't know, something below the runtime level of a JVM, then I'm definitely not the expert. So just to give you a little context here. But what I believe, especially in DevOps, is I think we try to push more responsibility to the developer. So let's say it that way, give them more opportunity to push their code safer into production. I think that's what DevOps in the end is all about. And so I think our goal and our mission as performance engineers have to be, how can we make our experience that we have available to every engineer out there that builds any type of code by automating our expertise into the delivery pipelines, into the DevOps pipelines. Because if, I think I had one example from Christian from ERT, he runs like 6,000 or so pipelines, right? I'm not sure how many hundreds and thousands of developers they have. And if everyone would all of a sudden start asking for performance tests, then I don't know how many performance engineers you would need if you would still say, I'm waiting for an email to run a performance test and then I'm sending them back an Excel sheet with the results. This doesn't work anymore. So therefore, we need to automate as much as possible. And also from what I've seen from my experience, most performance problems, especially in distributed systems on application level, can be detected very easily because there's only a handful of problems that at least I have seen that I typically see, right? It's like bad usage of your connection pools to the next system, inefficient database queries, the classical N+1 query problem pattern, some inefficient code. And I think we can automate both the test execution for this and the analysis by looking at the right metrics. And if we can build this all into your whatever tool you use, Jenkins or Harness or GitLab, and then a developer does a pull request, his stuff gets built, deployed, and then 10 minutes later, he gets a message saying, your code is good, it didn't break anything, at least from a performance perspective, then that's great. Or if he gets back, hey, something is wrong with your database access, try to figure it out yourself. If not, then you can go to the experts. So I think this is what, from my perspective, what performance engineering and DevOps need to look like. We need to automate our experience into our pipelines.
Yeah, I totally agree. And automating the entire thing and not just running, but also diagnosis, that would be very important, especially for APM tools, right?
Yeah, exactly.
And anyone else?
Okay, so let me try a follow-up. A little bit from the other direction, right? From not the application perspective, but sort of the low-level look. So every time I see talks such as the one from Google explaining how people spend half a year optimizing a hash map so that across the whole infrastructure they save 1 or 2% of execution time on all the hash map operations, I wonder whether we can really connect well the component performance and the end-to-end application performance. And it seems to me that that's a thing where we don't know really how to do that, right? We have large applications where they are essentially composed in a way that makes the performance of individual components largely irrelevant. So if I have a web app where some of the components suddenly have 10, 15, 20% worse performance or better performance, it doesn't necessarily have to be visible on the end-to-end application level. What happens is some latency somewhere goes up, so some auto-scaling adds a few more instances. So what I lose is not performance, I lose efficiency. And I wonder if we can do something in the DevOps loop to also address this, because usually, in my feeling is, or my experience is that the developers are at the component level, they are really disconnected from the performance problems of the application. And there's very little guidelines or guidance we can give them to make the code efficient at a smaller scale. So somehow I feel that we are trying to build a large house, not caring what the bricks look like. And that feels a little bit absurd, right? So to build a good house, I might also need to care about the bricks, and that's where we don't really have good answers, I think.
One argument here quickly. If we, like you brought up the example with, the efficiency. So what I always try to do is I'll try to put in efficiency metrics from an application perspective. That means how many log files do you generate? How many log lines? How much CPU do you consume? How often do you call to the database? How much memory do you allocate? How much memory is left over? And the thing is while I'm collecting this in the context of this little component that is just a small piece out of the whole end-to-end universe of an application, if you have, and now this is now where I have a benefit because I work for a company where we do end-to-end distributed tracing. So what we can actually then tell our developers that are responsible for one small piece, we can say, if you change this code, and if we look at what happens in production, where you have millions of transactions going through, an individual thing doesn't make a big difference, but because your code on a daily average is executed 1 million times, and now you're writing only 2 more log lines, it means that many more log lines that need to be processed, that need to be stored somewhere. So I completely agree with you. We need to figure out a way not only to tell them, hey, your code just went slower by 0.5%, but what does this really mean in the grand scheme of things? Because if this code is only executed once every year, who cares? If it's executed 10 million times a day, it's a different deal. Yeah.
So in my view, the main change that we have happens when we moved from waterfall development to iterative development. So we started to get changes all the time, and we need to have some kind of continuous performance testing to check for regression, because when I work for Oracle with Hyperion application, more on application level, and then I moved to MongoDB, where it working a little lower level, database level, and it is exactly the same problem. So we need to find regression, and we need to find it fast, get back to root cause. And that definitely something that cannot be done traditional way. And by the way, in MongoDB, while we started with change point detection basically on throughput level, now we are adding change point detection also on resource utilization, so and latency metrics. So to catch not only change in some summary kind of metric like throughput, but in other aspects of system too, because of course resource utilization is very important. One question that actually I'm very interested in and don't see much discussion, because yes, continuous performance testing is a must now in high-tech environment, at least. I think it is not, maybe not everybody using it. Maybe many organizations still use more traditional approach, but we will end there because looks like it has become mainstream. But this continuous performance testing is basically regression testing. So we catch regressions. What is worse? The question is interesting question. How we should complement it to do other aspects of performance engineering, for example, performance optimization, when we want to work on optimization of our code, or it less effectively work when we add new functionality. So yes, we add some additional tests to cover it. It starts to track from that point, but in the moment of introduction, it's still some work not getting outside of regression testing. And we can think about some other things like capacity planning guide. So we have a lot of work that not fit exactly continuous performance testing and still need to be done. And it is interesting that it not talk much about and not formalized in any way.
Yeah, so I think so far we have mentioned many interesting points. So for example, how can we ensure that we consider the number of execution of a certain component when considering the performance aspects of a component. So if a component is highly used or rarely used, their performance impact will have different purposes. And also Alex mentioned about for regression testing is just one thing, but there are also many other different things such as performance optimization that can also be integrated in the DevOps components. And so Ian, what's your take on this?
So I think I agree with all what you said, right? So but I think there's especially in the world of DevOps, right? So my take is, so a lot of the eyes and a lot of the energies are actually spending on these big boy players, right? So when we talk about performance testing, performance engineering, mostly we're thinking about these giants, Google, MongoDB, right? But the reality is, the majority of the markets are these medium-sized and small-sized companies, and the problem is not just the incapability of doing performance engineering. It's also they don't have the resource to do traditional long performance testing, right? And especially these small companies, they're dying to compete for their market shares, right? And even a small performance slowdown for them may be deadly. And so my experience is like they are very, very eager to improve their performance, so at least not to slow down their performance. But they don't have the money, they don't have the people to do this 24 hours, or they don't know how to do a proper performance testing, right? But DevOps actually gave them an opportunity to slip into this. So if we have the tool sets to catch stuff in early stage of development, then sure, maybe they can skip some of the performance testing they need to do, right? So the other thing is, I think a lot of discussions were really on development side, but I think really what also people can really do is trying to push things to the ops. So if we can do a very fast turnaround, so why do we need even testing? But maybe that's too extreme, right? But if we can turn around if we know your performance has some issues, then we know it in 2 seconds from proper monitoring, right? So maybe we don't even need that long scale testing, right?
If your architecture supports it, then that would be the ideal situation, right? That's basically what the big ones are telling us for the last 3-4 years, that we should use canary deployments and feature flagging, because then we can experiment in production and don't need any load testing anymore.
Exactly. But the thing is, functional problems are much easier to know, right? So if you have a crash, you will crash, right? You can replace a node right away. But performance are much more latent.
Yeah, but I think we have good enough tools, but then some of them are obviously not for free. So to your point, can every smaller player afford, let's say, the big APM players, where I include my employer as well? That's a good question, right? But I think we can, like what we have at least tried to do with our open source project Captain, we try to give you at least some type of tooling, so you don't have to invest in the basic automation of running performance tests and analyzing on key metrics. Yeah. Because I think there's just so many organizations are trying to build the same thing all over again, right? It's the same Jenkins pipelines that they build where they're calling some tool and then parsing the result. I mean, why do we have, nobody should need to do this anymore. And this is one of the problems we try to solve with our Captain project.
I see 2 different questions here. First, about not testing at all. I would say that many large companies actually push that approach, saying, like in best case, canary testing, but it depends what kind of products you have. Maybe it works for social networking or something, but I don't think that it is a good approach for banking industry, for example. Because even if you catch it quick, it's still get into production and somebody working with it. And if you get destroyed some data or crash. So basically, it is not you are not testing, you just use your customer to test it. So they become guinea pigs. If you're happy with that approach, and if customers are happy with that approach that they are testing, it may work, but it depends. It could damage reputation, and if it happens often, so that is first aspect. And second aspect that you mentioned, yes, I think we don't have tools, proper tools, because yeah, we have quite a lot of load testing tools, and some of them are better, some worse, but and I just posted a blog post talking about this continuous performance testing, and somebody just answered 2 cases as example of that, which probably good tool as far as I know. But problem is not load testing tool, but some kind of ecosystem. If, for example, you see what say people from MongoDB talking, Peter presentation, Andy presentation about Captain. Load testing tool is just one important but small piece of the whole picture. When you need, it should be something more sophisticated. And when I worked for Oracle, I needed to do it myself because it was a remote part of Oracle, so we were autonomous. I was pretty frustrated to do that simple stuff of plumbing of these tools together, because in my perspective, everybody needs it. So that it should be kind of either in load testing tool or some other tools like Captain, for example. And with what MongoDB did or what Peter told us, big infrastructure built actually custom. So a lot of efforts, good results, but it is not tool per se. It is a complex combination of some tools and a lot of custom work. So we didn't get to something that middle-sized companies with, say, person with limited performance engineering expertise could take and deploy. That I fully agree is a big problem, and except Captain, I don't even hear much effort in that direction. A little bit, some load testing tool vendors moving in that direction. I guess Neotis, K6, some plugin for JMeter, but it is far from the whole ecosystem that people could use.
I'd like to add a little bit of a different perspective. I am kind of like, I missed the first 2 hours of this meeting, so I might be off by something. But what I feel is this, most of the discussion is about, performance testing in the context of DevOps, which is highly automated and so on and so forth. I want to inject a little bit of a different perspective, because in my personal experience and my personal opinion, the majority of performance engineering is outside of DevOps. It cannot be as easily automated as such. One example is one previous presenter just showed us how to use algorithm to explore the maximum SLA. That is a growing chart with the as you increase the workload intensity, increased utilization of system resources. I can't remember his name, my apologies. But that chart, his results are very relevant in this discussion, as in the chart or the table he presented has a shape. And we have very well established mathematical models that can describe that shape. And in many, many cases in my real life experience, the test result of that shape doesn't match the mathematical model of the calculation of the same resources, the same code. And if we dig deeper, we find out it almost always somewhere buried either in the configuration or in the code, or sometimes worse, in the third-party libraries, that some system resources are not properly allocated. Someone's grabbing too much memory, someone's allocating too less of a system buffer, and so on and so forth. Now, these things take a long time, a lot of iterations to come up with the baseline data set. So to the original example, to come up with that table or to come up with that shape, it takes many iterations. And then you need to do analysis based on that shape. And that is very, very difficult to iterate. And obviously, we also need to consider the noise of the performance test and the modeling. When we do the modeling, we have lots of assumptions, and we need to see if these assumptions can or cannot be applied. So things are more complicated than just automated performance tests. In other words, I often say that performance results are not a number. It's a multidimensional matrix. You have the data set as one dimension, you have the workload intensity as a second dimension, and you have system resources as the third dimension. These are at least the 3 dimensions, and we have more if we want to get more complicated.
Following up on your observation, so I was wondering always that in many cases when we see a strange performance anomaly, what follows is a sort of an adventure digging through the system, trying to figure out what's happening. And on one side, this is very interesting because one learns a lot about the system. On the other hand, it's really honestly a waste of time, right? Because we examine systems that change quite fast. So by the time we figure out what's happening, maybe there's a new version of something somewhere which bypasses the problem we are seeing. And overall, our impression is that surprisingly large number of performance regressions we see are due to the systems being fragile in terms of performance. So we see regressions that are not sort of an inherent result of architectural bugs, but they are more like strange coincidences of too many things playing together. And these turn out to be, for us, most costly to analyze and sort of most problematic. So I wonder what's your experience when you look at the application level performance. Is it always bad luck on the main path, or is it or do you also see effects like these? And is this a problem when the application starts behaving strangely due to very complex interactions of components that are partially by chance really in there?
So far, I've been here for a while, being in the industry for a while. I have never seen a performance engineering problem that cannot be resolved if we want to find the root cause of it. There are cases where applications went, slightly off, but we have models that can calculate and can justify. For example, if someone claims that because the application was someone introduced a lot more business logic into the application and therefore is 200 milliseconds slower, we can calculate how much CPU time you should use and how much response time should be changed based on that calculation. And if your result matches, that, we can say it's justified. Otherwise, something else is happening. And there's one example to that extent is there was one case that we calculated your CPU, because of your added business logic, you increase the CPU utilization by 10 milliseconds per transaction. Now, if we see your average end-to-end response time increase by 10, 15 milliseconds, we'll let it go. Our test results show that you increased by 50 milliseconds, right? So that is not something that can be justified. Based on the model, we say that something else is going on, and we took some time to find out Yes, indeed. Something else is going on because the extra 10 millisecond, the application is occupying extra 10 millisecond on the open port to the third party. Now that third party connection is done by a third party library. And that third party library by default, it's not documented, by default only allows 2 concurrent openings. Now 10 millisecond on every connection, that puts the utilization of that 2 channel from 60% to 80%. Because of a queuing delay, you have an extra 40 millisecond of queuing delay on that 2 channels. And that makes all the difference. If and the developer team, actually, they didn't look at it. I look it up. I look up the source code of third-party library and saw that, hey, there's a 2 in your code. You should change that. It's open source. You can compile it. And that solved the problem. So things like that happen quite a lot, almost on a, well, I won't say on a daily basis, but on a per project basis in my work. The ones that can be identified by automated tools, for example, if Jenkins say this thing is a little bit slower and flags it, those things are trivial. Usually things are more complicated when Jenkins or performance test tools in general cannot generate the result that we are looking at. So things get more complicated when you need half a dozen test results to compile a data set, to compile 1 point of the data set. And then, as iteration goes, to make a point to the developer saying, hey, I think there's something wrong in your code, and this is why I think so. To generate that chart takes a week.
I would say that we shouldn't discount either side. So we definitely have a lot of work, and usually it takes much more time, and practically you cannot plan for it for performance troubleshooting or performance optimization when you try to create new kind of workload test. That takes a lot of time and definitely not related to kind of automation. That it's something kind of going a little bit outside, although it's with some kind of tools, it may be part of tools. For example, MongoDB has level of automation where you could run these different performance experiments a part of the system, so you get all kind of data and charts ready, which is helpful. But from another side, as I mentioned, it looks like for actual iterative development, you cannot get away without any kind of automation, because otherwise, again, when working at Oracle, I started to do it not because I wanted that, but because when we get to that regression in a month after it was introduced, it's real pain to get back and figure out what it was. And if you get it next day, usually it is pretty easy to fix. So basically, again, due to performance investigation and projects can take long time, I then found often myself that after I spent a week or two investigating some problem and getting back to the baseline performance, there was some kind of degradation, and then it started long time. And when I implement even simple kind of continuous performance testing, at least I was able to catch it quickly. But from another side, it had a lot of additional efforts to check what these results are. With a lot of variability. Is it variability or actual performance problem, and efforts to maintain that tools. So yeah, that definitely a trade-off, and I wouldn't say that. And where this trade-off should be, it is open question. And to comment on Peter comment, actually, I would say there are some tests that are less reliable, so results generally discounted, but usually if we see noticeable change in more reliable tests, it is some kind of issue, and the higher system is in from architectural point of view, the more components there, and the more chances that something is wrong somewhere.
Is anybody already starting to doing some chaos engineering, or whatever term you give it, where you're on purpose inject some chaos, like simulate a process that is consuming all the CPU or memory, or slowing down artificially connections, killing processes? Because that's also a great way, I think, for us performance engineers to not necessarily test for performance, but obviously test for resiliency, because in the end, you cannot always solve a performance problem by adding more hardware, by fixing the problem, but you can maybe architect around it to make the system just more resilient by default. And at least I've seen more people talking and doing and trying to do chaos engineering as part of the performance engineering practices, meaning running a load test and then on the side also enforcing some chaos and validating if the system can still produce stable results, even though there might be some chaotic situations happening in the underlying runtime infrastructure or something like that. Is anybody doing that?
I think so. So I think I don't remember which ICSI. So I think maybe probably the last physical ICSI. So there was like an industry talk from Netflix. So they well, Netflix is all about chaos engineering, right?
Yeah, true.
All stuff. So they I think the talk is mostly about performance. That was pretty interesting. So basically, they do all these crazy things. Yeah. But not, I think, not in the way of load testing. So they do not do that during the way of load testing, but in their way of their regular chaos testing. So they will inject the performance stuff.
Recently, we've done some study on that because it's cloud-based, and we need to decide if the failovers are within parameters. So it's not, we don't use the name chaos test. I think it's more like a failover, but again, people are interested in how long the failover completes. So it's kind of a performance related, and I was involved, and so far the experience hasn't been smooth. We learned a lot during the test, and usually it's more about how to put things together than how to tweak the parameters, because if it works, then things works really well. And if it doesn't, usually some configuration error. So it's just my personal experience. I'm just starting on in this field.
And it is interesting how that get that name, chaos engineering, and also originated more in production, looks like. Although it definitely just kind of reliability or resilience testing, which somehow was dropped from radar of performance engineering at some point. So, and actually we do that mostly around kind of maybe fault tolerance, or with some experiments with replication sets, with MongoDB running as replication sets with several nodes. So for example, what happens if we kill one node and how quick he will be updated up to speed when we get it back, or how it impacts the whole performance. So that kind of question, more than just adding some kind of resource problem. And I actually, this fault injection, I saw quite a few papers around about that, including databases. So it looks like very popular topic at the moment. But yes, it is a little sophisticated, but because main part is proper setup and what you want to measure, it is not so straightforward.
We've had a little bit similar situation. So it turns out that when we are trying to measure small pieces of software and we try to simplify our work by keeping noise down, keeping all the interference down, essentially that sometimes tends to lead us into systems which are not practically relevant. So for example, we've had an issue where because our servers were dedicated to running the same benchmarks over and over again, those benchmarks had very specific memory allocation patterns. And those memory allocation patterns were reflected, somehow played together with the allocation strategies of the kernel. So we always got the same physical pages on our machines, which meant always certain usage pattern on the caches, which ended up making like 20% difference in performance. So we actually had to introduce artificial noise into our environment, artificial memory allocations, artificial reschedulings to different cores to get a system which doesn't tend to fall into sort of local optima of behavior, which are not representative of the whole performance. So it's not exactly chaos engineering. We didn't inject faults, but we had to inject additional resource utilization operations to get our system into a shape where the performance data is relevant. By the way, I had a question to Andy. So do you think this automation is made more simple in certain domains? So I don't know, we do quite special thing. Testing compilers is not so common, but I see that in many cases, the applications are similar in that they have a REST API, they have the typical front-end, back-end database architecture. So do you think that this automation becomes simpler when people tend to arrive at sort of a unified, less variable architecture of applications where they don't have to configure so many things, they don't have to write so many special scripts because they just fit into certain pattern that we know how to test efficiently?
I would agree. Yeah, I would say yes, of course. You know, the more you are putting people into an opinion, the more opinionated your system is that you want them to be part of, the easier things will get. But it's always a trade-off in the end, right? I mean, the trade-off is the opinion gives you great speed and efficiency if you do exactly what you want, what they think you want to do, and then if you need to break out and then break the opinion, then it's everywhere in life the same. But what I see, at least, right, for Microsoft, for the world that I live in mostly, distributed applications that talk to each other via REST, there it became, I think, very easy because you can automatically generate your tests against the API. You have tools that can parse your Swagger definitions and automatically create all of your test cases. You can then reuse these tests for performance testing. You automatically get most of the metrics through frameworks like Prometheus, and then modern APM tools really give you all the important metrics pretty much without any code or configuration change. So I think for application performance, life is definitely easier than in the world that you live in. I mean, I don't know your world that good enough, but I think so. Right? How many people build compilers and optimize compilers, and how many people build some strange applications, right? I mean, I
think it's a good thing that we see the unification. It's really, there will always be strange corner cases, but
yeah. But I mean, what drove us to invest in this open source project is because we have seen a lot of our teams building the same automation all over again in different projects and different stacks. And I showed one of my slides where we did an analysis on how much duplicated code we have across different pipelines, across different products that we sell. And there's just so much duplication in there that we said, why are we copying and pasting all of this if we in the end want to achieve the same thing? So why can't we just standardize this? And this is also one of the things we wanted to solve with Captain, providing an opinionated, standardized way on how to execute certain automation steps that we know need to be done in the context of delivery. And that's the test execution. We're using a standardized protocol to share test results, to do the SLIs and SLOs, right? And hopefully we can make our small contribution to make this easier.
And actually, I think at least we can classify it into two big groups, say kind of single application business. So for example, when you work on your main business, like, I don't know, trade system or some kind of application, you have it it on specific platform, and you have it with specific workload. So you basically need just to check in that combination. In some cases, it may vary, but it's still kind of very set environment. And another area is any kind of software vendors, which usually support quite different configuration and quite different workloads. And you often don't know what kind of that workload would be in, and maybe compiler is even more specific subset of that set. So when you need to, on the top of just testing all these different combinations, you have some very one more layer of specifics there.
Yeah, you have to have the same problem with MongoDB, right? You also need to know how people use the database, and many of them won't just tell you because it's full of proprietary data, so you cannot just easily access it. So if Andy's toolwork would contain some services to export somehow anonymized performance data, so that the people who build the individual components can take a look at how the applications work without having to beg for every scrape of data from the applications, that would be great.
And actually, current trends to strengthen privacy law, which probably is a good thing, but that creates some additional problems for us, because I remember old times it was rather easy. Customers often were happy to share data and didn't care much, but now everybody cares so much about privacy. So even there is a lot of instructions that even the customer, if you given you something, you need to remove and destruct it as soon as possible. So that makes it more difficult to do that. And with anonymation then you get to question how much you need to anonymize. Do you still can get some grains of private information there in some indirect way? So you get some additional law to prove that you really removed everything.
Yeah, that's true. I was also thinking, you mentioned initially those canary releases, A/B testing, etc. So that's another topic where the component vendors or component implementers are restricted compared to the application vendors, because you can do your testing on the users if you have the end product, but it's much. I don't think there's a simple way to try few versions of MongoDB through the users of MongoDB on the end users of the applications. So that's another thing that would be nice, but it's not there.
So in this case, it is a little simpler now. Theoretically, we don't do that because a big part of MongoDB business is cloud business. So Atlas with MongoDB set up. So theoretically, we probably could just roll out update to all cloud installs and see what happened. But I strongly believe that it never happens, because even after all these tastings that we do, sometimes it's something gets there and create big problem for our customers. So I couldn't even think about nightmare of doing that.
I think it's interesting. I think the history just keep coming back, right? So if you this topic, I think like how to test the vendors with different workloads. I think 20 years ago, the DB2 has the exact same problem, right? So basically, they just want to optimize for every of their vendors. That's why like IBM invented this autonomic computing, right? And they have this model basically instead of the model on your design, they have the model on your runtime, and they just give up on pre-development optimization and just do everything post-deployment. Right? But I think maybe it's time that we pick it up again to see whether you can work in the DevOps world.
On mainframes, you had very good instrumentation and it was centralized, completely under single control. So again, in cases when you have your system in one place and under your full control, and it is not so critical, you could allow much more. Then you have multiple installs, different configuration, and critical business.
Yeah.
Yeah, so thank you very much for all the panelists and all the participants for engaging. And I think we had a very vivid and very active discussion. And unfortunately, the time is up. And so after the panel, we will still have one research paper talk, one industry talk, and one more keynotes. And please stay for the remaining of the program, since we will have very exciting presentations and very exciting keynotes. And Alex will take it over for the chairing and sessioning.